So today I want to go through the AA gradient, which is also called the P large A minus A O2 equation, or AaDO2 equation. It has a few different names. And in this equation, which is on 9-4 in your OAKS and in your calculation sheet, then you can see that we're subtracting the large AO2, which is the alveolar O2, subtracting the arterial O2 from that. So what I've done is I've put in some pretty normal values here for us to practice the first time through. So plugging those into the equation, the P large AO2 is 100, the P small AO2 is 95, and then subtracting gives us 5. And since both of the originals were in torr, then the answer for this is in torr. So now I've plugged in some different values that we calculated last week for the P large AO2. So I'm going to put in that and then subtract a P small AO2 and arterial oxygen. That makes sense as a value. And then I calculate and come up with an answer of 61 torr. The AA gradient normal value is about 5, and it can go up to about 600. So whenever you come up with an answer, you should always try to figure out if it's possible. This answer is a possible answer. It's a bad score for the AA gradient, but it's not the worst that you could have. So I want to move on to calculating the AA gradient really more the way that it's usually calculated, which is to calculate the P large AO2 first in the same equation and then calculate the PA gradient after that, or the AA gradient after that. So what that really means is that I have to go back and get my equation for the P large AO2 and put it in here. So positioning that so that it is got the equation in the same place, I'm now going to put the whole equation together. So you can see it looks like this. A little bit more complicated, but not too complicated, as you'll see in a second. So I have to get some values to use. So I have put in some normal values, or I should say some values, they're not really normal, for this equation to be used. 60% for the FiO2, 753 for the barometric pressure, 47 water vapor, CO2 64, RQ 0.82, P small AO2 or arterial PO2 61 torr. So I'm going to plug them into my equation over here. So filled into the equation, it looks like this. 60% times 753 minus 47, and then subtract the CO2 of 64 divided by the RQ of 0.82, and then subtract the PO2 of 61. So subtracting 753 minus 47 gives me 706, and dividing 64 by 0.82 gives me 78. And multiplying 706 by 0.6 gives 423.6. If I subtract the 78 from the 423, then I get 345.6. This is actually my large AO2 from up here. And then I subtract the 61 arterial PO2 from that, and I end up with 284.6 torr. So that's how you would carry out the that's the AA gradient. You would carry it out by using all of these values combined together, rather than just using the P large AO2 given to you. You would usually have to calculate it with all of this stuff. And that's how you'll be practicing it.